What is a fundamental theory in science? We hear about theories like gravity, relativity, and evolution all the time. But what makes a scientific theory fundamental? Well, a fundamental theory is one of the strongest and most profound ideas in all of science. It's an explanation that helps us understand how the universe works at its deepest, most basic level. It's not just a small piece of the puzzle. It's the framework for the entire picture. So let's break it down and really get to the bottom of what makes a theory fundamental. First, let's clarify what a theory in science actually is, because it's a word people often misunderstand. A scientific theory is not a guess, a hunch, or just a random idea. It's a comprehensive, well-tested explanation for some aspect of the natural world. It's built on a mountain of solid evidence, gathered through countless experiments, meticulous observations, and rigorous testing. A theory gains strength and becomes more widely accepted as more and more proof supports it from different angles. It's the highest level of understanding we can achieve in science. So, what elevates a regular theory to a fundamental one? A theory becomes fundamental when it explains the basic underlying rules that govern nature itself. Think of it like this: if the universe were a game, fundamental theories would describe the absolute core rules that every single player and piece must follow, no matter what. These theories describe the essential forces, the elementary particles, and the universal laws that apply to everything, everywhere. They don't just explain one isolated event. They provide the foundation for understanding a vast range of phenomena. Let's look at some famous examples to make this clearer. The theory of gravity, first described by Newton and later refined by Einstein, explains why an apple falls from a tree, but it also explains why planets orbit the sun and why galaxies hold together. Quantum theory is another one. It describes the bizarre and fascinating behavior of tiny particles like electrons and photons, which is the basis for everything from computers to lasers. And of course, there's the theory of relativity, which revolutionized our understanding of space, time, and gravity. These theories are fundamental because they shape everything we know about physics and cosmology. But here's a really important question: can these incredibly powerful theories ever change? The answer is a definite yes. Science is a dynamic process, not a static book of facts. Even a fundamental theory can be modified, refined, or even replaced if new, compelling evidence emerges that contradicts it. Scientists are always asking questions, challenging existing ideas, and searching for a deeper truth. That's the beauty of science. Our understanding of the universe is constantly evolving as we discover more. This constant search leads us to the ultimate goal for many physicists: the theory of everything. This is the name for a hypothetical, single, all-encompassing theory that would perfectly connect all the fundamental forces of nature. It would unite gravity with the quantum world, explaining everything from the tiniest subatomic particles to the expansion of the entire universe in one elegant framework. We aren't there yet, but it's the grand ambition that drives much of modern physics. Someday we just might find it. So now you know, a fundamental theory isn't just an idea. It's a powerful, evidence-backed explanation of how the universe truly works at its core. It's our best guide to understanding reality. Which scientific theory do you want to learn about next? Let me know in the comments below. And if you enjoyed this journey into the heart of science, don't forget to like this video and subscribe for more mind-blowing content. Thanks for watching.